algebra. We want to discuss for a minute the domain and range when we're dealing with a function, okay? Domain is your x value, and your range is the y or whatever other value it ends up as when you do the function. All right? So let's go to page 52, and you're going to see they list a domain for number 22 on page 52. They show this table: 4, 6, minus 5 and 3, and 6, and a minus 3, and minus 5, and 5. Okay? So basically, I'm going to prove it in a minute, but I'm just going to tell you right now that if you have more than one, if you have the same number twice in the domain, but not the same number that it relates to, see, this is 5 and a minus 5, and this is 5 and 3. So if that one, its function is the 3, this one, its function is 5, that is not a real function. That cannot be. Okay? You could list it again, but the number that it has to be the same. If you have two of the same number and they're different y values, then it is not a domain. And that's all that this is showing us here. Now, let's go figure it out. Page 54. Well, here, we'll show you this real quick, okay? So, f of x equals x squared plus 3. Okay, that's our function. So let's go ahead and just put down a range, a domain, and a range. All right? And of this function here. So let's just do 1, 2, let's do it the other way. Let's do 3, 2, 1, 0, minus 1, minus 2. And for each one of those, we get a range, or the y value. So when we plug the 3 into our f of x, what do we get? 3 squared plus 3.
9 plus 3 is 12.
12, okay. 2. 2 squared is
4.
plus 3.
5. Wait, oops, I bet 9. 7.
7. 1 times 1 is?
2, right?
1 times 1. 1 times itself?
Oh, 1.
1 times 1 is 1, plus 3 is
4.
4. 0, okay, we get 3, right? All right, minus 1. Minus 1 times a minus 1 is positive 1. Plus 3 is 4. So we get this same number again. All right? You can have the same number show up in the range, but if it shows up in the domain, it has to be the same number as it is for the other domain. Minus 2. Minus 2 times 2?
It's positive.
Okay, positive 2 times 2 is 4, plus 3 is 7. Okay, so here's what I'm showing you, is that here we don't have any duplicate domain numbers for x, but we do have duplicate numbers because they're a function of them. All right? And because this is a squared, that's easy to see that your minus numbers are all going to be positive. All right? So that explains the theory behind this domain and range. You use this for plotting it on a graph. All right? We're not going to do that because, for one thing, it doesn't solve any problems. This is your solution to whatever you're trying to figure out. But this is the theory behind it when they say domain and range. So if you're looking at a question, like the question here on page 54, number 57, all right, it says determine which of the following relations is a function. When you're looking at, you have F, G, H, and J possibilities. All right, you have a -3 and 2. You have a 4 and 1. You have a -3 and 5. All right. So, do we have more than one of the same number in our domain? Domain meaning X and the range Y. So when you put them this way, it's always assumed that the first one is X, the second one is Y. That's just the standard way you do it. So you got a -3 and 2, 4 and 1, a -3 again. Is it 2? No. So whenever you have more than one of the same number in the X column in the domain, and a different number in the range, then this is not a function. All right? So, F is no. Okay, G, you've got 2 and a -1, 4 and a -1, and 2 and 6. Do you see two numbers the same in the X? X is 2 in two places. But Y is a -1 and a -6.
What problem are we on?
Page 54, right here. 57. Okay? See, -3, 4, and 3.
Okay.
But it's 2, 4, and 5. That is not the same as that. That can't be a function. 2 and 1, -1, and 2 and 6. Same number in the range, but different numbers. Same number in the domain, different numbers in the range. Hence, that is not a function. H, -3, -4, -3, 6, 8, and -2. You have two -3s in the X and two different Y's. Hence, that is not a function. J, 5 and a -1, 3 and a -2, -2, -2. Are there any duplicates in the X?
J.
No, in the X. The X or domain. 5, 3, and a -2. That's what you're looking at, to see if any of these are duplicates, and if they are, is the range the same? Because if it's not the same, it's not a function. But if there's no duplicates, if this was 8 instead of 5, then yeah, that could be a range, a function. Because they're different with, there's no duplicates. That's what I'm trying to say. Okay, so you can just look at the numbers that they give you and determine if they are a function or not. So let's go all the way to page 61. All right. Okay, what they're saying on number 27, okay, you're looking at page 61 under spiral review, and they give you a little table of domain and range. And they want to know, is it a function? Okay, so let's just write down what they're putting here. Okay, they're saying that for 27, the domain is -3, -1, -1, 1, 3, and 7. All right? Are there any duplicates there?
3 and wait.
-3 and 3.
Then no.
Yeah. No, there are no duplicates.
Yeah.
So first of all, if there's no duplicates, then you don't even care what the range is. As long as you have different numbers here, it can be a function.
Okay.
All right. It's only when you have duplicates are the range then the same? Because if they're not, then it's not a range. Okay, that was pretty easy. All right, next one. 0, what would that one be? That would be number 28. They say 0 and 2 and 3 and 5, and then 0 and a -1, and -2 and 4. -2 and 4. Okay? So looking at it right here, we can tell it can't be a function. We have 2 duplicate numbers, but not duplicate ranges. Two x's that aren't the same as the 2 y's that are listed. Hence, it's not a range. All right? See how easy that is? They spend pages and pages trying to explain that. All right? So now we are, okay, pause it. Started. Okay. So now, just a reminder, we don't have time right now to do the homework, but I'm going to write it down that I gave you last time, just so, in case you missed it. All right? We just did on page 54, we did number 57. 57, that's the one we just did. All right, so now we're looking at our homework is page 61, numbers 27, 28, and 29, and then, 26, 27, 29, then 31, 34, 35, 36, 37, and 38. All right? 1, 2, 3, 4, 5, 6, 7. Okay. And these are not too scary. So, page 61 takes us over to 38. Yes. All right. That's it. Just wanted to do that range and domain. Thank you.